Welcome to a Unity course. Hi everyone, and welcome to this Unity course. In this course, you will learn how to create a simple hyper-casual car dash game from start to finish. Here is what you will learn: setting up a Unity project, configuring the environment and lighting, importing models and shaders, understanding object-oriented programming principles, implementing custom shaders, using the Dutin library to create smooth and crisp car movement. I will be with you every step of the way, updating this course weekly with the new features and logic enhancement. The best part? Once you enroll, you will have lifetime access to all future updates and exciting content. So, let's get started and make something fantastic together.
Welcome to our Unity course. In this lesson, we will be creating a new project. So, let's start. First, choose the editor version. Now, select the 3D template because it's a 3D game. Give your project a suitable name and choose the location where you want to save your project. And hit Create Project button. Our project takes some time to open, it's depend on your system. So, that's it for this lesson. I will see you in the next lesson. Welcome back. Now that we have created a project, let's take a first look at the default layout. Personally, I don't like to work with the default setup. So, let's customize it. In the top right corner of the Unity's interface, you will see a layout drop-down menu. Click on this drop-down menu to see the available layout options. I prefer the tall layout, so I will select that. Feel free to choose whichever layout you prefer. Remember, you can customize all the tabs according to your preference. I like to have my hierarchy and project tab on the left side of the screen. And I place my scene and game tab in the middle of the scene. Okay, before we go any further, let's switch our project to Android platform. Go to the files and select build settings. In the build settings window, choose Android, click the switch platform button. This process might take a little time. It's a good practice to switch your target platform at the start, especially if you are planning to make an Android game. You can switch your platforms later, but it will take extra time as Unity will need to reconfigure some files for the new platform. So it's done now. Close the tab. Now you can choose the aspect ratio. I'm choosing this one. We have set up a project and switched to the Android platform. We are ready to continue. See you there in the next lesson. Now, what's our next step? If you guess importing models, you are right. Here is what we need to do. First, download the resources file provided in the course material. Extract the contents of the downloaded files. You will find several folders containing models and shaders. Select all these folders and drag them into your Unity's project window. So, we have imported our models and shaders. Let's take a closer look at what we have got. So, here you can see several folders. Inside this models folder, you will find various type of models. A car folder contains different car models. We have coin model, lamp model, rock and trees model. If you go back to the main folder, you will also see a couple of shaders in this folder. And inside this, you will find some ready-to-use prefabs of tree and rocks. A quick note. These models are provided strictly for learning purpose. I am not the owner of these models and they are used here to teach you how to work with different assets in Unity. If you want to use different models, that's even better. It will challenge you and enhance your learning experience. Okay, so now drag one of the car model from the car folder into the hierarchy. Next, we need to adjust the main camera. Select the main camera in the hierarchy and change the following settings. Change the Y position to 21, change the X rotation to 35, and change the Z position to -14.44. Adjust these values until the camera view looks good. Now, we need to add a ground. For that, go inside the path folder and open the center folder. Now drag this model into the scene. And adjust the Y position of this to place it correctly. Let's adjust the directional light. Select the directional light in the hierarchy and change the following settings. Change the X rotation to 161, Y rotation to -29, and Z rotation to 15. In the light component of the directional light, change the following settings. Change the shadow strength to 0.7, change the bias to 0, and normal bias to 0. Now our shadows looks perfect. Next, create a new folder in the assets. Name Materials. Open the shader folder and select the gradient skybox. Drag it into the materials folder. You can use this shader by dragging it into the scene window. Customize the sky color and ground color according to your preference. I am choosing a sky blue with a hint of greenish tint for my sky. If you want to use the same colors, you can copy and paste this code. Let's adjust the ground color as well. Customize the sky position and ground position. Our sky position is -0.02. Our ground position is -0.26. That's perfect. To prevent our sky color from reflecting in unwanted areas, open the Windows, Rendering, Lighting. Place this tab wherever you prefer. Click New Light Settings to create a new light settings and rename it if you want. Now change the following settings in the lighting window. Check real-time global illumination and uncheck baked global illumination. Set the directional mode to non-directional. And set the light map parameter to default very low resolution. In the Environment tab, change the skybox color to color. Choose the color you prefer. You can copy the RGB's values to use the same color as mine. Now enable the fog and select the fog color. Set the density to 0.01 and at the last, generate lighting. That's it for today's lesson. See you there in the next lesson. Hey guys, welcome to a new lesson. In this lesson, we will generating a path for our car. So, let's get started. First, we need to create an empty game object and rename it to path. Let's remove the center object for now. Actually, we don't need to remove it. We can just re-edit later. So, grab the center model again and place it as a child of the path game object. Now, we need to adjust the Y position of the path. Select the path and set the Y position to -1. That looks good. Next, go back to the path folder and choose the mid model. Drag it into the scene and set its position. You can use the shortcut key F to snap it to the nearest object. It's better to rename it. I'm calling this left mid. We need an object on the right side as well. Simply duplicate the left mate object using the shortcut key Ctrl+T and rename it right mate and place it on the right side. Now we need the last right model. Drag it into the scene and adjust its position using F. Rename it. Similarly, we need the last left model. Drag it into the scene, adjust its position and rename it last left. Next, we need a barrier on both sides. Drag the barrier model into the scene and adjust their positions. This looks good. Now, select the path game object, right click, choose 3D object and then cube. Move the cube to the desired position. Now we need to set the scale. X is 50, Z is 10 and reduce the Y scale to 0.1. When you zoom out a bit, you might notice a visual difference. This isn't a glitch. It happens because a cube has a default material, while our other models use custom shaders. Let's create a material for our cube. Open the shader folder, select the curve world shader, right click, create a new material and rename it Greenland. Now move it into the materials folder. This material will use a custom curve world shader. Choose a green color for the material and attach this material to the cube. Now it looks good. Let's create a land areas for left and right sides. Rename it left land. Duplicate it again. Move it to the right side and rename it right land. As you can see, all left and right lands are empty. We need to add some trees and rocks here. So, create an empty game object and rename it left tree and rock. Duplicate this game object and rename it right tree and rock. For the left side, create 3 more empty game objects and rename them 1, 2 and 3. Do the same thing for right side as well. Under the models folder, you can find different types of tree and rocks. We need a combination of both. So open the tree and rock folder. Here you will see various prefabs. Randomly choose any prefab and drag it into this and set its position. Repeat this for 2 and 3 as well. Do the same thing for right side. You can delete the empty game objects and duplicate this one on the left and dragging them into the right. Now reset the names and positions. removing the minus sign from the exposition. That's it for the path. Now we have a complete path for our car to navigate. Finally, let's create a new folder called prefab and drag the path folder into this new prefab folder to keep everything organized. Now, let's duplicate the path and move it to see how it looks when we're generating the path in game. Don't worry, we will handle the path generation by code later on. This is just to showcase you how a path will look. Have you noticed this curve? That's what we need for this game. Pretty cool, right? Now let's delete all the duplicate paths except the first one. Next, we need to add colliders to our path components. Open the path prefab. Select center, left mid, last left, last right, and both barriers. Add a box slider to each of these models. Make sure the colliders are set properly for each models. For the barriers, increase the height of the box collider to act as an invisible wall in our game. Save the path properties and go back to the scene. You can create varieties in the path to keep the game interesting. Duplicate the existing path prefab, unpack the prefab. Now delete the tree and rock prefab. Add some random tree and rock prefabs here one by one. Once you are happy with the new arrangement, make it a prefab by dragging it back into the prefabs folder. Now we have two varieties of the path. You can create as many different paths as you like for more variety in your game. For now, we can delete the additional paths from the scene. In the next video, we will start coding to generate the path dynamically. See you there in the next video. So, it's time to generate a path using our code. First, create a folder called scripts. Inside this folder, create a C# script called Path Manager. Now create an empty game object and rename it to Path Manager. Reset its transform and attach the Path Manager script to it. Now double click to open this script in Visual Studio. Here, first remove the start and update methods because we don't really use right now. Add a serialized field private game object array called path prefabs. Add another serialized field private game objects and call this one first path. We need an integer called path count and a float variable called zPathSize. Now we need a list of game objects called pathList and initialize it to a new list of game objects. Create a private constant float, call this one position_by and set it to 0. Now create a private void start method. Here, Set the z path size to a first path dot transform dot get child index is 0 dot get component renderer dot bounce dot size dot z. Let me explain this to you. In Unity, you can see that first path is our initial path. Inside this path, the first child object index is 0 is our center object. We need the z value of this object to store this in z path size variable. Now add a first path to a path list like this. It's time to create a new function called spawn path and call this function in the start method. Inside spawn path function, create a for loop. Replace the loop length with path count. Create a game object called path and set it to instantiate path prefab random.range 0 and path prefab.length. Create a vector3 variable called path position and set its position. Add quaternion.identity as well. So now calculate the path position as pathlist pathlist.count minus 1 dot transform dot position plus vector3 dot forward multiplied with z path size. This code grab the last path in the list and move it a bit in the z direction. Update the path position dot z value like path position dot z plus equal to position bias. Finally, add the new path to our path list. Save this script and now go back to the Unity. Move our path inside the path manager and rename it to first path. Select the path manager and attach the first path to the script. Go to the prefabs folder and attach the path prefabs. Set the path count to 25. Save the scene and hit play. As you can see, a path is generating perfectly. Open the path manager script again and remove the serialized field from z path size, as we don't need to show this in our inspector for now. To clean up the hierarchy, update the script to set the path's parent. Like this, path.transform.parent is equal to transform. Save the script and go back to the Unity and hit play again. Now it looks good. That's it for this lesson. See you there in the next lesson. As you can see, in the last lesson, we generated a path for our car. In this lesson, we will start working on the car, so let's get started. First, we need to download an asset from the asset store. So, go to the Windows Asset Store and click here Search Online. It will open your default browser. Here, simply search DG Training. Now, choose this free version and download it and open it in Unity. Now here, simply import the whole asset into your project. After importing the asset, a tab will pop up. Open the Butane Unity panel and set up Butane. Now remove the tick from UI, Physics 2D and audio for now and hit apply. Now close the tab. Now you can use your Butane library. We need a Butane library to move our car left and right. We can use a simple code as well, but I think this is the easiest and performant method. So now I'm changing my car name to player for the better understanding. Now go to the scripts folder, create a new C# script called player, select the player and drag the script. Now unpack player object completely so we can add the important components here. First we need to add a rigid body. Inside the rigid body, change the angular drag to 0. Now add a mesh collider. And place it at the top. Also move our rigid body component as well. So let's write some code. Double click to open your player script in Visual Studio. Here, first remove the start and update functions. At the top, we need to use dg.tuning library like this. Now we need a couple of variables like public float left lane 1 and left lane 2. We need a public float center lane, public float right lane 1 and right lane 2. That's it. So now save the script, go back to the Unity. Here we need to set up all the lanes values. So select the player and see. We don't need to change our center lane because our player is at the middle right now. Look at the player's X positions. Now move our car a little bit in the left side. So this is our left lane 1. So copy this value and paste it on the left lane 1. Same as it is, move the car more in the left direction. Make sure it's set correctly. Now copy the value and paste it. Same thing we need to do for the right lane as well. Right lane first is 4. And right lane second is 8. Now set the player's X position back to 0 again. And open our player script again. We don't want to change these values, so add here constant. You can use here Alt plus arrow down key to change all these lines at once. You can see it gives me an error because the constant float requires a value to be provided. So let's add a value here one by one. Our left lane 1 is -4, our left lane 2 is -8, our center lane is 0, our right lane 1 is 4 and right lane 2 is 8. Good. Now save the script and go back to the Unity. As you can see right now, variables is not showing in the inspector. That's good. Now we need a private vector to call this start touch position and a private vector to call end touch position. Create a update method. Also create a function called swipe left right. First, call this function in the update method. Now, let's write a logic inside our function. So, first of all, remember this function is only work in the mobile and the Unity's simulator. So keep that in mind. Now check if input.touch count is greater than 0 and input.getTouch 0.page is equal to touch page.begin, then our start touch position is equal to input.getTouch dot position. Now we need another if statement. If input.touch count is greater than 0 and input.getTouch 0.phase is equal to touch phase.ended, then our end touch position is equal to input.getTouch 0.position. We need another check in this. If end touch position.x is smaller than start touch position.x, it means player swipe the left. And if end touch position dot x is greater than start touch position dot x, then it means player swipe the right. Now let's create another function called move right and move left. Inside the move right function, we need to use transform.doMoveApp function. Here, we need a float parameter called lane. Now add this parameter here. We need another float variable called smooth move. And add this here. Same as it is, copy this line of code and paste it here. Now we have move right and move left function. Let's call these functions with some conditions. If transform.position.x is equal to center lane, suppose transform.position.x is our car, and if the car is in the center, we can move it left and right. Inside this function, player can only swipe left or right. Our car only move left lane 1 to left lane 2nd. Inside this function, player can only swipe left or car only move left lane 1 to left lane 2nd. Add a move left function and choose left lane 1. Now copy this line and paste it here. And change center lane to left lane 1 and call this move left function. Now change the parameter left lane 1 to left lane 2. So our car is in the center lane first. When we swipe left, it changes the lane, center lane to left lane 1. And when car is in the left lane 1 and we swipe, then car change the lane left lane 1 to left lane 2. I hope you understand. So now copy this and paste it here. Change the move left function to move right function and change parameter left lane 1 to right lane 1. Now change here also left lane 1 to right lane 1 and move left to move right and left lane 2 to right lane 2. So now let's just test this for the better understanding. Save the script and go back to the Unity. Let's hit play. Our X position of the car is 3.46. It should be equal to 0 because 0 is our center lane. And also swipe is not work in the game tab. So switch the tab to simulator. You can choose any device you like. Now open the player script again. Now add a private rigid body component. Call this one RB. Now create a wake method. Now give it a reference to our RB. And we need to set RB.center of mass to vector 3.0. Now save the script and go back again. Hit play and see our car X position is now -3. Still not 0. So we need to freeze the X and Y position of this car and also freeze the X, Y and Z rotation of the car. Don't forget to set smooth move to 0.2 or any value suitable for your game. Now hit play. Now swipe left. Yeah, now it's working. But when our car is in the left lane 2 and left lane 1, or swipe right is not working. So let's fix this. Let me explain this code. So first, we check if the car X position is equal to center lane 1 and player swipe the left, car move to the left lane 1. And when our car is in the left lane 1 and player swipe the left, then car move left lane 1 to left lane 2. So now our car is in the left lane and we can only swipe the right to change the lane. we need to add a line of code here. Check our transform.position.x is equal to left lane 2 and player swipe the right. So we can use move right function and now give it a parameter to left lane 1. Now copy this line of code and paste it here. Now change the left lane 2 to left lane 1 and change the left lane 1 to center lane. Same, we need to do this for swipe left when car is in the right lane 2 to change the lane right lane 2 to right lane 1. I know it's quite confusing, but it is the easiest logic. So check here, if transform.position.x is equal to right lane 2, then use the move left function and give it a parameter to right lane 1. Copy again and paste and change right lane 2 to right lane 1. Inside this, right lane 1 to center lane. So that's it. Now you can change the lane seamlessly. So save the script now and go back to the Unity and hit play. See, now you can move your car left and right direction using our swipe control. I hope you like this lesson. If you have any problem, you can share with us. I can provide you all the scripts if you're facing any errors. See you there in the next lesson. In the last video, we learned how to use swipe control to move our car left and right. In this video, we are going to add a dash-like effect in the game with the help of our built-in library. So let's start it. First, open the scripts. Here, we need to add some variables. Start by adding private bool rotate left. Set this to false and add private bool rotate right and set this to false as well. Now add the serialized field private float variable called smooth rotation speed and set this to 0.2. Next, duplicate this line and change the name to rotation degrees y and set it to 15. Copy this again and paste it and change the name to rotation degrees z and set it to 5. Finally, add a float variable called LR sign. Now let's get the value of LR sign in the awake method. Our LR sign is equal to negative method of sign transform.position.x. This function basically returns the sign of our transform.position.x. We simply grab the value and store it in LR sign variable. Next, create a new function called private void rotate left. Inside this function, check if rotate left is true. If it is true, use transform.doRotate to rotate the car with the new vector 3 of 0, 0, 0 and use smooth rotation speed to control the rotation speed. After this line of code is executed, set rotate left to false. Now add an else statement. Copy this line of code and set rotate left to true. We need to add y and z values here. First, add rotation degree y, multiply with LR sign, and then add rotation degree c, multiply with LR sign. That's it for the left rotation. Now we need another function for the right rotation. Copy the entire rotate left function and paste it here. Change the function name from rotate left to rotate right and change all the instance of rotate left to rotate right. Now it's time to call these functions. First, find the move right function and call the rotate right function on start. Then call it again on complete. Similarly, we need to call rotate left function, so copy the line and paste it. Replace rotate right with rotate left. That's it. Now save the script and go back to the Unity. Select the player and you should see that all the variables have values. Hit apply and as you can see, when we swipe, our car rotate a little, give us a dash-like look. However, there is a small problem. Our car rotates only in one direction. Let's fix that. Open the player script again and inside the rotate right function, add a negative sign in front of rotation degree Y and rotation degree Z. Now save and test again. You can also play these values to create a unique effect. But for now, I am happy with these settings. In this video, we are going to work on a camera movement. So let's get started. First, we need to create a script for the camera movement. So go to the scripts folder and create a C# script called camera movement. Once the script is created, select the main camera in the scene and attach the script to it. Open the script in Visual Studio. Now let's begin by removing the start and update methods since we don't need them right now. Declare a serialized field private transform called player. This will hold a reference to the player's object. A private camera called main cam. This will reference the main camera. A private vector 3 called original pose. This will store the camera's original position relative to the player. Next, we will create the start method to initialize the camera and calculate the original position. In the start method, assign the main camera to the main cam variable by writing main cam is equal to camera.main. Now, set the original position variable to the difference between the camera's position and the player's position. For that, write original pose is equal to transform.position minus player.position. Let's create a late update method to handle the smooth movement for the camera. In the late update method, we need to smoothly move the camera to follow the player. To do so, write transform.position is equal to vector3.smoothTemp transform.position position. Let's create a vector3 variable called pose. This will store the desired position of the camera, which is the player's position plus the original offset. Write vector3 pose is equal to player.position plus original position. We also need another vector3 variable called velocity. This will be used in the Lookdev function to calculate the camera's velocity over time. Vector3 velocity. Now, let's create a float variable for the smooth speed. Add the following line of code. Serialized field private float smooth speed. This will allow us to adjust how smoothly the camera follows the player. Now, add this variable in the Lookdev function we wrote earlier. Once the script is complete, save it and go back to the Unity. Select the main camera and in the inspector, drag the player's object into the player's field of the camera movement script. Now hit play to test the camera movement. As you can see, the camera smoothly follows the player as they move around the scene. That's it for this lesson. Everything should be working correctly. In the next video, we will continue improving this game. So, see you there. Hey guys, welcome to the new lesson. It's time to move our car, so let's get started this lesson. First, open the player script. Uh, Let me adjust these functions like this. Now it's good. Now create a private void fixed update function. Inside this function, write rb.velocity is equal to vector3.forward multiply with, let's create a variable for that. Serialize field private float move speed and set this to 20. Now add this variable here and multiply this with time dot fixed delta time. We are using the time dot fixed delta time. I think 20 for the move speed is not enough. So let's set this to 200. Okay, so now save the script and go back to the Unity. Select the player and hit play. See, still 200 is not enough. You can use a higher value here, but I think we should just simply remove the time dot fixed delta time. Now I think move speed 50 is enough. Yeah, it's quite good. That's it for this lesson. See you there in the next lesson. In this lesson, we will see how to generate a path endlessly. So let's get started. First, select the Path Manager and open the Path Manager script in Visual Studio. Here, we need to make our path endless. For that, create an enumerator function called reposition path. Inside this function, check while true, add here yield return null. Now create a float called destroy distance and set this to camera.main.transform.position.c minus 15. Now check if path list. Here we need an index, so let's create that. Private integer list path index and set this to 0. Now add this here. .transform.position.c less than destroy distance. So if this statement is true, then we need to generate the new path. So here, create a vector3 next path position and set this equal to first path function. Don't worry, we can create this function in a second. .transform.position plus vector3.forward multiply with z path size. Now let's create this function. This function will help us to find the farthest path. Write game object farthest path. Inside this, write game object this path is equal to path list with the index of 0. Now create a for loop here. Replace the length with the path list dot count. Inside this for loop, check if path list with the index of I dot transform dot position dot c is greater than this path dot transform dot position dot c, then this path is equal to path list with I index. Now simply return this path. Make sure you write this outside the for loop function. Now let's move back to the reposition path function. We calculate our next path position already. Now set next path position dot z plus equal to position bias. Now write path list with list path index or transform dot position is equal to next path position. What we actually do here is we just simply move the old path to the new path position, so we don't need to spawn and destroy our path every second. This method is good for our game. Now, after that, increasing the list path index like this. Check here if list path index is equal to path list dot count, then our list path index is equal to 0. Okay, that's it for the reposition path function and the farthest path function. Now let's call this function in the start method. Start coroutine, because our reposition path function is an enumerator function, and this is how you can call an enumerator function. Start coroutine and then the function name like this. So Now it's time to test it. Save the script and go back to the Unity. And now hit play. Now it's working perfectly. Select the path manager and see our path is now spawn and destroy. It's just changing its position according to the player's position. Now check. What if we double our car speed? No problem. Let's check the FPS. If you don't know how to check the FPS, simply find the state option inside the game tab. So currently it's 240. It's quite good. So congratulations to you all. Our base is ready. So that's it for this lesson. See you there in the next lesson. As you can see in the previous videos, we successfully create a base for our game. In this video, we will add other cars in the game. So let's get started. So first, create an empty game object. Rename it called other car manager. Inside this, create another game object called active cars. Now duplicate this and rename this one unactive cars. Open the scripts folder and create a new C# script called other car manager. Now attach this script to the other car manager object. We need one more script called other car controller. Open the prefab folder. Here, create a new folder called path and drag our path inside this folder to keep things organized. Now create a new folder called other cars. Okay, so now let's add some other cars in the game. So first, open the models, go to the cars folders, and here simply open the random folder and choose the model and drag them to the hierarchy like this. Select all the cars and unpack the prefab completely. Add a mesh collider in these cars. Make sure you select all the cars. Inside this component, check this convex option. Add a rigid body component. Here, set the mass to 3. Now add other car controller script here. Open the prefab, other car folder, and drag our cars one by one inside this folder. So delete all the cars from the hierarchy. That's it for this lesson. See you there in the next lesson. Okay, so now open the other car manager script. Delete the start and update method. Here, write serialized field private game object called active cars. Duplicate this line and rename this one to unactive cars. Now create a serialized field private array of game object called car array. Create another serialized field private integer called initial car numbers and set this to 50 for now. Now we need a public float called this one a car frequency. Add another public float called reverse car frequency. Now set a range in both variables between 0 to 1. Save the script and open the Unity. Now select the other car manager and first drag the active car object and unactive car object. Now set the car frequency to somewhere around 0.225 and reverse car frequency to 0.063. You don't need to copy these values. Just play the game and test it. Now see, at the top right corner, there is a lock icon. Simply click on this icon. Now go to the other car prefab folder and select all the cars and drag it into the car array. Now make sure to unlock this tab lock, otherwise you would be worried why I can't see other objects properties. Now open the other car manager script again. Here we need a private vector3 variable called previous car position. Set this to vector3.0. Now create a start function. Inside this function, we need a for loop to instantiate other cars. So create a for loop. If you don't know the shortcut key, let's just write for and then press your tab button twice. Now replace the len to initial car numbers. Write game object called car and set this equal to instantiate a car array. Let's use Unity's built-in function to randomize the index. For that, we need to use the Unity's engine.random.range 0 for the first index, and for the last index we use car array.length. Now write car.setActive to false because at the first we need to hide the car. Let's set a car.transform.parent is equal to an active car.transform because our car is set active to false. Save the script and go back to the Unity. Now hit play. And pause the game. As you can see inside the inactive game object, 50 car instantiated. When you check the position of all the cars, it is the same and we don't want it. So open the other car manager script again. Here we need to find out all the position to place a car. So let's create a list of vector3. Call this list car position. Here we use the game object parameter called the path. Inside this function, write a list of vector3 called list path position and set this to new list of vector3. Create a for loop here. Replace the length with the path.transform.childCount. Inside this for loop, write a local vector3 variable called position and set this to the path.transform.getChild with the index of y.transform.position plus new vector3 0 1 0. Now at this position in the list path position, write list path position dot add position, and here outside the for loop simply return the list path position. So that's it for this function. This function helps us to find out all the car position to place a car. Now create another public void check and disable car path function. Inside this function, first we need a list of vector3 called list car position and set this equal to our list car position function, which is right here. Copy the name and paste it. It's give me an error because here we need a parameter as well. So for that, let's create a new serialized field private path manager. Call this one path manager. Now open the path manager script. Inside this script, find the path list. Now replace the serialized field private with the public because we want this in our other car manager script. Also, make our list path index private to public. Now save the script and open the other car manager script. Now you can write here pathmanager.pathlist and pathmanager.pathlist_index, and we need to create a car. So for that, check if Unity engine.random.value is less than or equal to car frequency, and here car frequency is a float variable. We need a local vector3 variable called this car position and set this equal to list car position Unity engine dot random dot range between 0 and list car position dot count. We need another check. While car position dot x is equal to previous car position dot x, and previous car position is a vector 3 variable. Inside this statement, write car position is equal to list car position unity engine dot random dot range 0 and list car position dot count. Now outside this while statement, set a previous car position to car position. Let's move for the random car. So create a game object called car and set this equal to get random car function. So let's create this function, game object get random car. This function will help us to get a random car. Inside this function, write a game object car is equal to unactive car dot transform dot get child unity engine dot random dot range 0 and unactive car dot transform dot child count dot game object. And now set a car dot transform dot parent is equal to null and car dot set active to true. And at the last, simply return the car. So that's it for this function. Now set a car dot transform dot position is equal to car position and check if unity engine dot random value is less than or equal to reverse car frequency. Then set car dot transform dot rotation is equal to quaternion dot Euler 0, 180 and 0. And set of car dot transform dot parent is equal to active car dot transform. So this function is done now. Create a public void find car and reset function. This function will help us to find all the car run out of camera and reset it. For this, we need a for loop. Replace the length with active car dot transform dot child count. Now here, check if active car dot transform dot get child with the index of I dot transform dot position dot c less than path manager. Open the path manager script. Inside the reposition path function, we need this variable, but right now it's a local variable and we can't use this in a other car manager script. So let's create it outside. Remove the float from here. Now write public float destroy distance. Good. Now save the script and open the other car manager. And here write path manager dot destroy distance. If this statement is true, then write a game object called the car and set this to active car dot transform dot get child I index dot game object. Now set the car dot game object dot set active to false and the car dot transform dot parent to unactive car dot transform. So that's it for this script. Here we successfully create a find car and reset function. Check and disable car path function, list car position function and get a random car function. So now save the script. It's time to call these functions. So open the path manager script. Here give the reference to our other car manager script. Now inside this function, simply write other car manager dot check and disable car path function, and outside this if statement add other car manager dot find car and reset function. Now save all the scripts and go back to the Unity. Here in the other car manager script, give the reference to our path manager and select the path manager, and here simply give the reference to our other car manager. Now it's time to hit play. As you can see here, active car and active car updated automatically. You can see different car now show in our path and see the FPS is around 225, which is quite good. So that's it for this lesson. See you there in the next lesson.